Alright, welcome to Chemlight. Today we are going to be looking at another section on alcohols. We are going to be focusing on what? Laboratory preparation of alcohols, industrial preparation, properties of alcohols, and finally the uses of alcohols. Okay, now you see this part, this section is full of jam questions and it's very important for you to focus, pay attention and grab it. It's very necessary. Now there will be a lot of synthesis here and the other synthesis. When we're talking about synthesis, we're also going to be looking at what? Preparations of alcohols, reactions of alcohol, but that will come later on. So now we'll pay attention. This is very important for you to understand the synthesis. Okay, so now let's move on. Now, first of all, the laboratory preparation of alcohols. This preparation of alcohols is what called what? Hydration of what? Alkenes. Catalytic hydration of alkenes to what? To yield what? Alcohols. Alright. Now, how does it happen? Now, any alkene at all is reacted with what? Water. Now, this reaction can only take place in what? In the presence of a mineral acid. That's this H plus you are seeing here. A mineral acid, what do we mean by mineral acid? We can use H2SO4, we can use HCl, but most times H2SO4 is preferred in some reactions because sometimes HCl can start interfering with the reaction and you don't want that, trust me. Okay, so basically we need a mineral acid for this reaction to take place and it will give us an alcohol. Now if you look at this structure is the structure of what? Ethene. Now ethene reacts with a water molecule in the presence of a mineral acid. Now the double bond is broken and two hydrogens from the water molecule is being added and the oxygen is also added, giving us what? An alcohol, and this alcohol is called what? Ethanol. Alright, this is one way to prepare alcohols. Now the industrial method of preparing alcohol, this part you have to pay close attention. Alright, now on the industrial preparation of what? Alcohols, we are going to be looking at fermentation. Now, fermentation is what? It is the microbial decomposition of big molecules like what? Starch, which is a what? Polysaccharide, to give us a smaller molecule like alcohols. Do we understand? I believe we understand that simple definition. But now, let me explain the way this thing works. Okay? Now, starch here, which is a what? Polysaccharide, is what? Acted upon a enzyme, which diastasis is the enzyme. This enzyme is gotten from what? It's gotten from malt. Take note. It's gotten from malt. Now this enzyme acts upon starch to give us what? Maltase. Maltose. Alright? Now maltose is now acted on another enzyme acts upon maltose to give us what? Glucose. Now this enzyme which also acts upon maltose is from what? Yeast. Take note of all this. This can be questions, jam possible questions. Okay, this enzyme comes from yeast. We act upon maltose to give us glucose. But that's not all. That's not all. How do we get alcohols from this reaction? There will be a further reaction on what? The glucose. Now for glucose, an enzyme again also from what? Yeast. Take note of all this. Zymase. Zymase is an enzyme from yeast which acts upon glucose to give us ethanol and carbon dioxide, or also known as carbon dioxide. Alright. So on that note, this is not the only way in which we can get alcohols. For example, we also have what? A disaccharide, which is what? Sucrose. Sucrose is gotten from what? Glucose, which is a monosaccharide. Monosaccharide plus another what? Another molecule which is called fructose. So glucose and fructose join together. The both of them are monosaccharide. They join together to form a disaccharide called what? Sucrose. Alright. Like now, take notes. Starch is what? Polysaccharide. Maltose is what? Disaccharide. This guy here is monosaccharide. Also here, the same thing, okay? So now, here now, this guy is a disaccharide formed from what? Glucose and fructose. So now, an enzyme called invertase Also from what? Yeast. Take note. Invertase is also from yeast. When invertase acts upon this guy, what is it going to do? It will split it. When it splits it, it's going to give us what? Glucose and fructose, which are monosaccharide. But we don't need fructose here. That's why I just left glucose, because we are going to further react glucose with what? Azynase, also from yeast, to give us what? Our ethanol and carbon dioxide, or also known as carbon 4-oxide. Alright, this is what the industrial preparation of alcohols. So right now, let's move over to what? Properties of alcohols. Alright, for the properties of alcohols, we are going to be focusing mainly on what? Ethanol, to be specific. Now, the properties of alcohols, to be specific, ethanol, we have what? Ethanol has high boiling point, which is what? 78 degrees Celsius. Alright, hope you know why I write these things down on the board before explaining them. Writing them during the video might take a long time. Video that is supposed to be like 10 minutes video or less is going to be like 20 something, and you don't want to be wasting your data for nothing. The most important thing is what's the information. Alright, so let's continue. Now, why does ethanol have a boiling point? It's very simple. It's because of hydrogen bond. The hydrogen bond in alcohols keep forming hydrogen bond with each other, making what? The boiling point to increase. Alright, now secondly, it's neutral to litmus. Alcohols are what? Neutral to litmus. Now, they don't indicate if they are acidic or basic, because what? Alcohols are amphoteric. It does not show red, neither does it show blue in litmus paper. Alright, note that. Now, it undergoes oxidation reaction. Now, this is the most interesting part in this video. Make sure you pay attention. It always comes out in jam. Now, for the oxidation of alcohols, we have the incomplete oxidation, complete oxidation. In fact, chill. Now, let me break this thing down for you. First of all, we have what? In the latter part of the series, we talked about primary, secondary, and tertiary alcohol. I explained on those. So now, if you don't understand what primary, secondary, and tertiary alcohol is, I will refer you to go and watch the former videos. Okay, so now, incomplete oxidation of primary alcohols will yield what? It will yield aldehydes or alkanals. Please, I know why I'm calling the two names, because most of us or some of us might think they are different. It's going to give us what? It's going to give us what? An alkanals, or what? Aldehyde. Alright? Now, incomplete oxidation of primary alcohol, note it, primary alcohols will yield alkanals or aldehydes. Now, for the complete oxidation of the same primary alcohols, what are we going to get? Now, we are going to get what? Alkanoic acid. We are going to get alkanoic acid, or what? Carboxylic acid. Is the same thing. Alright? Now, for this one, oxidation of secondary alcohols. If we oxidize what? Secondary alcohols, we are going to get what? A ketone. Alright? Also known as alkanones. Alright? So now let me write it. Ketones. I don't have space to write alkanones, but it's the same thing. Secondary alcohols will yield ketone, or what? Alkanones. Note that. Now, for oxidation of tertiary alcohols, actually it's not going to yield anything. There is no reaction. It's not going to yield anything. Take note of all these things. A very vital point in which you should note for yourself. Alright. Now, other properties of alcohols, like what? Esterification. Now, what do we mean by esterification? Esterification is what? The reaction between an organic acid. Now, which organic acid are we talking? To be specific, we are talking about what? This guy. Look at him. Alkanoic acids, carboxylic acid. Now, if an organic acid, which is what? Carboxylic acid, react with an alcohol, it will give us what? Esters. Now, these esters, you might not, if you've not heard of ester, you must have heard of what? alkanoids. Esters are also called alkanoids, so take note of that. That's what esterification means. Now, aside for esterification, we have what? Dehydration. Now, for dehydration of alcohols, how does it work? It yields two products depending on the condition present. Now, how do we dehydrate alcohols? Is by what? Using what? Concentrated H2SO4 to dehydrate it. Now, what do we mean by dehydration? We mean removal of water molecule. Now, if we are going to use concentrated H2SO4 in this reaction, why is it that it gives us two products? It depends on the temperature. Now, if we are to get alkenes, the temperature will be what? Above what? 180 degrees Celsius. Alright? The temperature will be above 180 degrees Celsius. Now, if we want esters, we will make sure this temperature does not get to 140 degrees Celsius. What do I mean? I mean that the temperature should be what? Below 140 degrees Celsius. It's going to give us esters. Alright, finally, these are the uses of alcohol. I had to write them down so I don't skip anyone. Now, there are different type of alcohols here with their different type of uses. Now, first of all, the first member, which is what methanol, is used as what? Antifreeze and what? Making plastics. Okay. Now, for the second member of the family, which is what? Ethanol, is used in making drinks, fuel, solvent, disinfectants, perfumes, esters. Alright, now for propanol is used as solvent and what? Antiseptics. Alright, now the final one, which is what? Glycerol. I think we talked about glycerol in the latter part of our video when we're talking about what? Monohydric, dihydric, trihydric, and polyhydric. Now this guy is a trihydric what? Alcohol. It has what? 2OH. Sorry, not 2OH, sorry. It has what? 3OH present in the what? Compound. Alright, so now glycerol is used what? In making explosive medicine and cosmetics. I think that will be all for this video, but in the next video we are going to be talking about mainly focusing on the synthesis, the mechanism in which what we do preparations and what reactions of alcohols. Now, if you want me to make video on the synthesis of alcohols, make sure to state in the comment section. Alright, let me see what we have. Alright, don't forget your speed drop is always there. Go and check it out, it's always fun. Alright, thank you for watching.
Who you feel say he go win this year? BBN.
What be that?
BBN now, Big Brother Naija.
God have mercy upon us.
Bro, as you big rich, bro. See question where they ask me, bro. Big Brother Naija for 2025, bro.
Ouch!
Country they spoil, they watch BBN. I be your brain do BBL.
Jesus.
Country they spoil, defend BBN winner.
Oh, Jesus.
They check rate too. I grown up man like you go, they watch BBN. Which kind of feminine movement be that, bros? You they see period?
Oh my God!
Now, small question I ask you now. Which one say you can't enter me like this now?
Baba, how person go there at for midnight, they watch people where they sleep. Are you allergic to sense?
So that means you know they watch BBN.
I rather watch Tom and Jerry.
Maybe like so many people there will be say they complain about and they know they watch am.
So many people they complain say they don't know they watch am. All the millions of views, what would they see? Who they watch am? Them ancestors. I been AI they watch am.
So wait, that means the way they para now, you know, just like the program. People where they do the program, they waste money.
May government banner give us good out message. It's shout to me they give us cocoa melon.
But you know if you say the program they assist the government, they empower the youth.
The only youth empowerment program I know for Nigeria na sporty bet. Bet Nigeria Aviator.
Unlike from him, I hear what you talk.
Bet King.
He do it.
They empower waiting not good.
One man.
Okay, you now as a gamer, just tell me why you watch BBN now. You as a gamer, why you watch BBN?
Now because of all the girls who get big yash, I make me the watch.
Are you serious?
Guess we get big yash.
Yes, now.
I make you watch BBN.
Yes, now.
You they see your life because of Nyash. You are a finished man.
Fear, I pour you spit.
Bro, where's your dignity? Where's your reputation? Where's the station?
Which station?
The station was the show now.
Nigeria, they see you.
No, me